So first of all, the general method of separation of variables. And here's when it works. It works when you're faced with a differential equation of the form f of x times g of y. That's the situation that we had, and I'll just illustrate that just to remind you here. Here's our equation. It's in that form, and the function f of x is minus x, and the function g of y is just y. And now the way the method works is this separation step from here to here. This is the key step. All right? This is the only sort of conceptually a remarkable step, which all has to do with the fact that Leibniz fixed his notations up so that this works perfectly. And so that involves taking the y over, so dividing by g of y and multiplying by dx. It's comfortable because it feels like ordinary arithmetic, even though these are differentials. And then we just anti-differentiate. So we have a function h, which is the integral of dy g of y. And we have another function, which is f. Note they are functions of completely different variables here. Integral of f of x dx. Now, in our example, we did that. We carried out this anti-differentiation, and this function turned out to be log y, and this function turned out to be minus x squared over 2. And then we write the relationship, which is that if these are both antiderivatives of the same thing, then they have to differ by a constant. Or in other words, h of y has to equal to f of x plus c, where c is constant. So now notice that this kind of equation is what we call an implicit equation. It's not quite a formula for y directly. It defines y implicitly. That's that top line up here, right? That's the implicit equation. In order to make it an explicit equation, which is what is underneath, what I have to do is take the inverse. So I write it as y is equal to h inverse of f of x plus c. Now, in real life, the calculus part is often pretty easy, and it can be quite messy to do the inverse operation. So sometimes we just leave it alone in the implicit form. But it's also satisfying sometimes to write it in the final form here.